Good evening. On behalf of the House of Sultan Chand Private Limited and Method I once again take this opportunity to welcome you all to today's AI webinar. It feels great to have you all here, and we thank you for that. A bit about the House of Sultan Chand first. Pioneers in the field of book publishing in post-independence India, we cater to students from primary to university level, churning out over 600 regular titles year on year, besides adding new ones. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in various schools and colleges across the country, as well as in the neighboring nations also. Thanks to your patronage, SCS today is a name to be reckoned with in the field of education. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you to the host of today's webinar, Dr. Sachin Gupta, author of the hugely popular Artificial Intelligence textbooks for classes 9 to 12. Dr. Gupta is Dean, Research and Innovation, Maharaja Agrasen Institute of Technology, Guru Gobind Singh Indraprastha University, Delhi. Besides, Dr. Gupta has also been HOD, Computer Science, Engineering and NCA Department, Dronacharya Group of Institutions, Deputy Director and Head, Computer Science Department, Chandrababu Jain College of Higher Studies, affiliated to GGSIPU, Delhi. With a teaching experience of over 23 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIPU. It's a matter of great pride for us that Dr. Gupta's book, Decoding Artificial Intelligence, has won the Outstanding Contribution to AI Literature Award. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are truly commendable. I now invite Dr. Gupta to take you through today's session. Thank you, Dr. Sachin Gupta.
Thank you so much, Manmohan sir. You are very kind. So we have had one session in Orange some time back, but Orange is one tool which is so powerful that people keep coming back. We always ask for more. So I have tried to keep it more interactive this time because you must have already been using Orange from long. And I want to ask that what are the challenges that you are facing or anything that you may want to share along, anything that you will make your life easier working with Orange. That is the basic purpose. I have taken three different use cases today so that we'll have ample time to discuss. And we'll start nothing but Orange itself. So I will start with a very small application of Orange, which we haven't used prior. Uh, and I hope my screen is visible.
No, sir.
Yes.
Not
Yes, sir.
yes. Okay. So the very simplest example that we are going to take today is that we have the iris data set, uh, which you must have all uh, seen. So iris is basically about three types of flowers that you would be identifying by their characteristics like petals, length, sepal width, and so forth. Right. On our first tab or the first widget that we have is the file widget. This would be helping us to fetch the data. Let me share again. Apple is suddenly not allowing me to share the complete screen as a. Okay, I believe now should be visible, right?
Yes, sir.
Yes,
Okay.
sir.
So Iris says that we have got sepal length, sepal width, petal length, and petal width. They are the basic four features. And the target is either setosa, versicolor, or virginica. That is, we are trying to do a classification based on the properties of the data that we have. We are just trying to find which particular type of flower would be there based on the parameters that we have. Then you can just simply add data by choosing from here or even selecting from the file menu that would allow you to select any of the data sets that you have available. There are inbuilt data sets you may use, but in case you do not want an inbuilt data set and you have a URL, you can place the URL here and it would work exactly fine. You can also import a CSV file instead of the table file, that the .tab. It could have been a CSV file that works equally well with it. That was part one. Then to the file, we are applying a simple classification tree widget. This comes from your model that would allow me to create a classification tree. If you look at it, it would ask you certain parameters, whether you want to induce a binary tree, what is the minimum number of instances in leaves. If there are subsets smaller than 5 or 4 or 10, then we don't want to split them. And then there is a maximum tree limit. We can take it to 10 because my data set is not very big. So that basically would allow me to work with it. Can somebody tell me, is classification tree a regression algorithm or a classification algorithm? Just chat, type in the chat window. I'll look at that. Is the classification tree a regression algorithm or a classification algorithm? Classification, where is classification, Shalu? Any different answer? Raja Rajeshwari says regression. Kavita says, okay, we have at least one conflicting voice. Understand one. Classification are called CART algorithm. They are classification and regression trees. So this is one unique structure which allows you to see both
Excuse
classification.
me, sir.
Yes.
No, previously the slides were not visible, so
I've just kept them on hold. Don't worry. I'll bring them back. So here your slide. Is it visible, right?
Yes, sir.
Okay. So classification trees work across both categories. You would be working with classification and regression. So this is something that is one unique point. How does the classification tree work? It basically, okay, another thing. I want to ask whether the classification tree is learning based or rule based. This is yet another question that is one of my favorites to ask. Gurminder, Varis, rule based. Go on. So everybody is agreeing. This is a rule based system. Correct. Let us go ahead. And I'll come back to this point again. So this is the classification tree it created based on the data that we had. There are 9 nodes. There are 5 leaves. The leaf nodes are below. Then everything else is a specific node. We have the depth up to only 5 levels, so that doesn't matter. That's how are we taking. We can add or reduce the size of the tree. Right. So for everyone who said it is rule based, I want to ask you another question. Did we give it any rules here? Who chose the rules? Where do we, how do we decide that less than equal to 1.9, greater than 1.9, if the petal length, that means there is no particular flower where the petal length is less than equal to 1.9. We have only those flowers where the petal length is greater than 1.9, then I decide on petal width. If the petal width is greater than 1.7, then I would classify it as one category. But if the petal width is greater than 1.9 and the petal length is less than 1.7, I have another category, then the third one, and so forth. Where do these numeric values come from? Can somebody tell me? If we have, okay, Gurminder, the rule is given by the programmer, correct? We have not programmed this anyhow. We have not given any rules here. Where to split? How does it decide that what is happening here? If I have to only look upon this, where did these values come from? Greater than 1.9, less than 1.9, or greater than 1.7, less than 1.7? Where are these values coming from? Can anybody answer that? Going through statistics we feed. Okay. Data set. Data set. Murli Shankar, if it is coming from the data set, you are right. But that means it is learning from the data, not from the rules, if I am right. You can open your mic anytime. I don't mind. So that comes from the data set, yes. And that is the reason why we say earlier models of classification tree were basically rule based, which we would create the rules. But when my classification tree is learning from the data itself and then creating a set of rules, these rules which are defined based on data set, that means we are learning from data. So every classification tree is basically learning based when we are using the term in the terminology of machine learning. Because feed it a lot of data, it is going to learn from the characteristics of data and then make a classification accordingly by its own. So that is one essential aspect of classification tree. So you already saw the viewer that this is the way it is going to break. It just tries to find out that where there are 50 out of 50 from the data, wherever the length, petal length was less than equal to 1.9, it was labeled iris setosa. So from the data set, it learned that the petal length, whenever it was greater than 1.9, it was iris setosa. So it created one category of iris setosa for any flower which had a petal length of greater than 1.9. After that, it starts picking up that if the length is less than 1.9, then I would have to check on petal width also. If the petal width is greater than 1.7, I am 97% sure that it is Iris virginica, right? But there is another thing. If the petal length is less than equal to 1.7, but the width is greater than 4.9, then there goes Iris virginica again. So Iris virginica is something which is not very clearly immediately available, but this data was created or this classification tree was created based on the data itself, not by us. So this is a learning based model. Please ask me any query that you want to ask in the meanwhile. Now from this, if we want to see, if we select the iris versicolor and we want to see the characteristics of it, we just selected that and it shows me a box plot which would give me the statistical detail of the chosen variable. All right. So this is a particular visualization that we can create maybe with selecting something else. So let us select the petal length and try to visualize it in the box plot. So you see iris versicolor, the petal length is, I hope you recall your statistic. Box plot gives you the middle value, 25% of the value is here, 25% of the value there, then goes into the remaining part. That means it is based on quartiles. So first quartile, second quartile, third quartile, and fourth quartile. Second and third are divided by the median and it shows you the mean value also. So for Iris virginica, you see that there is a lot of variation on one flank. For Iris versicolor, this is usually a very normal distribution that we have. Now, this was all possible through Orange. Anjali, we have one channel on YouTube that is Sultan Chand and Sons. There are a lot of videos and you will be able to find them. But I do training sessions for faculty as per request also. So this is your scatter plot. Another thing that we wanted to add for the classification tree viewer, based on the data, we want to see how do they fit in the scatter plot. Up with scatter plot, we want to see staple length, staple width, or any other parameter. But the best part of this is click on find informative projection, and this shows you which particular axis when you plot is going to give you the maximum information. So you see, okay, I did one mistake. I have already something selected here. Let us deselect petal length. Now there is nothing selected, so we would be able to see all of the data here. So for this scatter plot, I can find different projections. This is the first one for the scatter plot, right? I could choose the different one. This is going to create a graph between petal length versus sepal length. I may choose yet another sepal length and iris. There is no point doing this. So ideally, the first two are the ones which are going to give you most information, and these are the ones which we are using. If you want to see the shape to be changed, so this is the graph changing the shape of the particular points. You can select them by color, you can select them by shape also. Correct? So you can change the size by staple width, staple length. These are basically visualization options which allow you to let me keep the shape same. But now see that when I'm using the size of petal length, these are smaller, these continue to get bigger, right? And I may want to see the color regions and I would be able to see that how different types of color options or how different type of data sets are blended in together. Okay. This is basic for how we create a very small model in Orange, right? You can always save it as OWS file and export it. So this file is saved as .ows. It automatically keeps a track of the data as long as it's the same position on your screen. Any questions so far? I'm just closing this one for classification trees. This is done. Let us take in the second one. We have now Palmer penguins. This is a very popular project that was given by CBSE in the handbook, but they mentioned some parts of it, some parts they missed out on. So let us look at all the tabs that we have in Orange during this process. The first tab talks about data. You may include a file, you may include a CSV file, you may import a data set. If you look at the data sets, this is going to show you a lot of data sets which are available within an online repository which Orange supports. You can use a SQL table. This shows you how to see what is in the data set. So if I have putting a data table here and connecting it, it would show me what is there in my data set. So data table basically allows you to see the data set. This we can eliminate now. But and then you have information about data, ranking, color, feature statistics, and so forth. So for this data, there was we'll compare what happens when we have in a with this data table. See, there are 344 instances with 6 features and 0.4% missing data. There is no target variable. There are no meta attributes. That gives you the complete properties of this data. I wanted to now clean this data because there are missing values. So we have a imputation feasible. Impute allows you to do a lot of things like you may replace the missing value with the average or most frequent, or you may give it a distinct value, or you may give it a fixed value. Whatever that you want to do, you can choose. Right? For each of them, you may choose specific type also. So for species, if you want to, don't impute. For island, for this kernel length, you may want to add is a distinct value. You may choose. Right? So let me restore all to default for the time being. So it would just pick up the default value and apply imputation. After that, if I see the data characteristics again, after that, there is no missing data. That means whatever data was missing, that has been taken care of by my imputation operation. So far, so good. We can also see the feature statistics which show the distribution of the data, that how is data distributed in statistical domain. So you have the mean, mode, and median of each of these values that were numeric, and dispersion, minimum value, maximum value, and we see there is nothing missing with this. All right. So feature statistics is a very good way of teaching people data science also. That how do you see what is the distribution looking like? Is it a normal distribution? Is it exponential? Is it something which is neither of them? But so after that, your basic machine learning says that we should have a target variable. Okay. So from my data set, I wanted to predict the species based on these details. Right. Initially, you could start with everything back to the original data set, even this, and then I may simply take this to the target, select all of these, take them to the features, and that does it. All right. So this basically is my splitting of the target variable separately, and the features are separate by selecting the column. For each of the points, you would also like to see that there is something going on beneath this. At the bottom of a window, there is a clickable uh, data set which shows you that this is the particular column that we have chosen as a target, and the remaining one which are not selected are basically our feature variables. Okay, so far so good. The next step after my basic pipeline was I would have to fetch data, and then I clean data if there are missing values, if they I have to do normalization or scaling or anything. After that, I have to separate the target variable from the feature, and after that, finally you apply a train test split. You want to split your data into training and testing. Right? Orange does both things. One is Orange allows you to use a data sampler where you can sample 80% or 70% or 85-90% of the data, whatever that you want to do, right? And pick that out. So is my training data is into two parts now. The first part is 80% of the training data is kept once, 20% of the training data is kept separate. This is normally used to make sure that when my learner is applied, then I would be able to make some modification. I'm not testing it yet, but during the course of training, I am validating that what results am I getting, they are good enough or not. I would be testing them later. But for the time being, we just have sampled 80% of the data, training data in one, and 20% of the training data has been kept separate for the purpose of optimizing. Right. So you can see that 274 rows are going to the data sample, and the remaining data has got 68 rows. So I had a total before this started, there were 342 rows. They are divided into 274 and 68 by the virtue of 80% of that being correct. This is the part where I apply the machine learning algorithm. So test and score for each of the widget, you would see that just hover on it, let the cursor remain. It is going to show what type of input does it take and what type of output would it produce. This would also help you learn what type of widget should I apply here. So test and score has three inputs. It would take the data, it would take the test data, it would take a learner and a preprocessor. If the preprocessor is already applied to the data prior to my data sampling, then I don't need the preprocessor again. I just need three parts to it. I need the data, test data, and a learner to the test and score. So where the data coming from the sampler, I just I'll just block this. So let us connect the data sampler to test and score. Okay. See, this is a connector label. A connector label tells you what are you transferring because यहाँ पे हमने we divided the data into two parts, 80% and 20%. So data sample goes to data, but the remaining 20% should go to the test data also. This creates two connectors here, one sending from the sampler normal data and the other sending the remaining data to test and score. The next thing it requires is a learner. So learners are coming from my model. This tab contains all of the different learners which we may apply. But you would have to be very careful that are we trying to do a classification? If yes, we are going to use the classification algorithm from here. If we are doing regression or sorry, something which is more like a prediction, in that case, we will be using a regression algorithm. So linear regression for calculation, logistic regression for classification, that is the basic thing that you are going to work with. All right. So I apply a learner here. I can now bring in another because I could have used SVM also for classification. Right. From my data sampler, I connect data sample plus data. I connect this to test and score. So this is going to now get three things. My algorithm is SVM. I have got test data. I have got training data also. So this is going to be able to tell me that for SVM, all the parameters are working perfectly fine. It is giving me 100% correct classification on the complete data. So AUC, F1, precision, recall, all the parameters. And you can see what is the meaning of Matthews correlation or classification accuracy, all the parameters. And you can compare because they are no negligible, they are just negligible differences. So you may compare them by AUC only because there are no not much differences. So it would not give you any output here. Right. So we have got three different learners now. My test and score showed me three different results for all of them. But test and score gives you more. It can be converted to a confusion matrix. It can be also converted to a ROC analysis. Right. Now ROC analysis would create the graphs that how much area is under the curve. Okay. Confusion matrix would show you which model is doing a error. So let us look at this. There are 29 Adeli which were correctly classified as 29. There were 11 chinstrap which were correctly classified as chinstrap. There were 24 Gentoos which were correctly classified as Gentoos. There were two chinstraps which were incorrectly identified as Adeli. There was one Adeli which was misclassified as Gentoo, and there were one chinstrap which were misclassified as Gentoo. This is basically how you read out classification metric. But for the random forest, we see that there is a single misclassification that is happening. So from tree, we had 1, 2, and 2, 4. There were 4 misclassifications. I can see select misclassified from the bottom. So these blue columns are going to show me how many misclassifications are there. You can clear the selection. For random forest, if I see the misclassified, the total is 1. For SVM, if I see the misclassified, there is a 0 misclassification in here. Okay? So that is the way you would be able to interpret your confusion matrix. But even when I wanted to see that the random forest was doing one misclassification, let me find out which one was it. So I have selected this. Okay. After that, I go to my data table and see why this was misclassified or which specific value. So these values are something which would interest me. That what was different about these values that this actually was misclassified. Why should this be misclassified when others are being classified correctly, and so forth. Okay. There's a time to make predictions actually. So for predictions, I use evaluate from confusion matrices was from evaluate, ROC analysis was from evaluate, predictions is from evaluate, test and score is again from evaluate. If you hover on it, it is going to show you what it does. It displays predictions of model for an input data set. 2, it shows you which input does it take, data and predictors, and what output does it prepare that is going to be seen. So I have to give it the data plus the testing data. So model and predictors are coming from my learner. Each of the learner, SVM I have not connected. So this is taking the model and predictors from my learners because this is the model has been created by that learner. The learner took all the data, learned, created some inferences from it, created a mathematical model that how would I classify Gen2 or Adeli or anybody. I need to know what were their basic characteristics. And then finally, I did that. Now I want to test. My test data was kept separate. This was not a part of the training at all. And I feed the test data also into the predictions and click open there. Now when you click open this, if you want to see that, and these are the 3 predictions. Random forest said a daily, tree said a daily, SVM said a daily. Okay. Where did we make a mistake? So let us find out from here. Okay. So this said Chinstrap, this said Gentoo, this said Adeli, but it was actually Adeli. So this is something SVM is doing correctly. Here I find this said Adeli, this said Chinstrap, and this said Adeli. And it was actually Adeli. So this is basically where I try to test how my model is performing on the data which it had not seen prior. That basically goes into the prediction. Okay. All good so far? This one is about how to use your classification on Palmer Penguin dataset. You could have changed the dataset to heart diseases. You could have changed the dataset to, okay, let us just try to change because the test data I would not be able to find, but I can change only this part. Let us remove, let us change the dataset only. So let us train it on a different dataset. and we want to test it on a loan training of the loan data set. Okay. What happens now? This is going to populate the complete thing without actually having to do anything else. My models will learn again. They will learn from what? What was my input function? The feature statistics are different for the same, complete same flow. The data sampler did 50-20. The select column automatically said loan status is the one which we want to classify. Test and score gives me for different models the different output. I may want to see a ROC analysis. The ROC analysis for the three of them is shown differently. So this model probably works the best out of the three. Correct. So this one is the one which is having the maximum area under the curve. So this particular model works the best. Yeah. This has the minimum area under the curve. So this model is considered less good. Correct. And then we have a confusion matrix where the actual loan prediction was it would be given but was not, or the loan was not supposed to be given but it was. So you see the classification matrix again here for the two models that you have. Everything else remained the same. So any questions up to this? Let me open the chat window quickly. Okay. Shalu ma'am, for Palmer penguins, we have included the dataset link in our book also. So if you are following that in class 10, you would have the link available. But in case you don't find it, you can find a complete Palmer penguins dataset, randomly split it into two parts by the number of rows. Or first, just simply randomize the values, split some rows separately for the testing part, and keep some of the rows for the training part. You can do that. You can do it manually also. That doesn't matter. Any other question up to this? So let me take the last leg of this today, not saving. Okay, this is how we work with text. So this I believe I am doing for the first time here. My data is basically a file which is containing a lot of words, general everyday use words that we have. You can see the corpus has got a set of words that we are going to see. Let us look at the corpus. From the corpus, we take a corpus viewer. What is in my data set? My corpus viewer says there are certain number of words here. We have apple, arrow, banana, bed, blanket, book, bowl, and some words from the general common life that we have. Now, so far, the previous data set that we took had features which were numeric or which were converted to numeric because they were non-numeric categorical data, which we converted to numeric by encoding them. With text and images, we have to always encode the data from a different format like text or image to something which the machine may understand. So we have to convert it into something that we call as embedding. Embedding does what? It simply takes in the corpus and it outputs the corpus in a vector form or in a numeric form, which my machine learning algorithm can understand. Right. So if you want to see the corpus, a single word apple has been converted to how many features? Okay. There are 384 dimensions to this vector, which it has created. So every single word that we have is converted to 384 numeric values, which uniquely represent this. Any questions here? What we just did in simple words, we took a normal word, text. That text was converted using an embedding algorithm. Now there are multiple embedding algorithms that you can choose. So you can use multilingual expert or fast text. There are more algorithms which allow you to embed the document. But essentially, this particular thing converts your text data into numeric form in the form of a vector that a machine learning algorithm can understand. Okay. You may want to see that how does the data look like after it has been converted into vectors. So this is a multi-dimensional space where I can click on one, right? This was particular to piano. It has got the features because it had no features. It was simply a word. When I converted it to a numeric form, it now became something with a lot of features. The total number of features are 384 because that's what my algorithm was doing. So this is showing me for each of the points what features are available. But based on the features now, some are going to be placed close, some are going to be not placed so close. So this is a pillow and this is a doll and they have no relation. That is something that my algorithm sees that a dog and a pillow are far apart. They have got no correlation that you have. Okay. So the TSNE algorithms allows us to see that what is my, or it allows us to visualize that how do my numerical format vectors appear on a graph. Okay. From this, I would come to this part later, but for the time being, from the document embedding, let us look at, I want to compare that which particular data items are close, which are far. Okay. And there are different distance metrics. So cosine similarity is how are the cosine values of the vectors similar or different to each other, or how far are they? We could have taken Euclidean, Manhattan, Pearson, Spearman, Jacquard, Hamming. They are basically used for different algorithms for different purposes, but cosine similarity works with text completely comfortably. So you can experiment with these, that how good my algorithm goes with it. And after that, I am applying a network of neighbors that for each of these text words, I want to see three neighbors. I may make it four, I may make it less. Right? I want to see three neighbors of it and then explore it on the network. So for this, the three neighbors are given: earphones, headphones, earplugs, radio. Right? So I may want to see the model again, relay out that, but this is just going to keep it connected. We may want to make edges with large weights shorter and edges with large weights equal. That you can do. Okay. You may increase the edge width or you may increase the node size also. This is your choice. That having been said, we just saw the network. Now, what was the purpose of this is I wanted to be able to say, bring in a new word. Semantically, which of my complete corpus is this word similar to? All right. So I created another corpus, which I gave only a single word called music. This is the text word. How would I use it if I have to use it? Because corpus was a single word, I have converted all of the remaining data to what? To its embedded form, embedding. If I have to use this one also, I would need to convert it to embedding first. So I create a document embedding with the same algorithm which we used earlier. And now you can look at the data table that the new text was music. For music, it would again create 384 different dimensions or the vector form of the word music. And I can use this. I can use this how? I would be able to now take all the document embeddings from here, this document embedding also, and put that into a neighbors algorithm. So I want to check for the cosine distance metric and limit the number of neighbors to 6 and see the corpus viewer. So for music, because we got the all the embeddings from the complete data set. We got one new word, music. What is music? Very similar to by the cosine similarity or by the virtue of its embedding. So it is close to guitar, drum, jam, ukulele, piano, saxophone. These are the six things that the music word, wherever it occurs, this is going to be closest in distance to these points when we plot it on a mathematical graph. This is what it essentially says. Right? So if you want to see the network explorer, again, check out this is pencil. What it is close to is a pen or ink or notepad. So these words occur together. That means they are semantically similar, or in English language, they are usually used together, or they have some relationship which my model is learning again. Because after embedding, I'm just converting it to the raw numeric form. That numeric form, wherever something else with a similar numeric form would come, they would be placed closer on the graph. That basically creates a network of neighbors. So document embedding all data into this. My new word, let us change the corpus to fruit. We have taken a new word, right? Now this is embedding. After the embedding, it would create 384 dimensions vector. That vector is going to be stored to the neighbors. And I should have a different, that what is close to fruit should be coming in here. So for fruit, you have grape, lemon, orange, banana, and apple from my list. Correct. If I change it to animal, this should change again. But first, it would be a. So I see puppy, zoo, rabbit, elephant, ostrich. These are something coming close to. I may change this to something yellow. Let it embed first. And I see lemon, orange, banana, pot, rainbow. They are the things which are. I just want only three neighbors here. So which three are the closest to this value? For yellow, lemon, and orange are the closest to the word which I just showed. Okay. This is basically how do we work with text. For each of them, you would find a lot of widgets for transforming the data, visualizing the data, modeling the data, evaluating unsupervised or supervised learning. I don't need world happiness or spectroscopy, not in this, or geographical data. But yes, people do work with them. And if you don't find these tabs available here, so just go to options, click on add-on, and this is going to show you which specific widgets can you add. So I have included educational, explain, geo, text is there. So these are some which I have chosen. I may add bioinformatics also. So this would install the bioinformatics here, and we would see it coming up soon. It would have a different set of widgets for the different kind of data that it basically works with. All right. So I have now opening this to questions because you may have a lot, maybe less, any number of questions that you want. Please do ask so that we can help you with them. I think no question. Did it? Yeah, please just go ahead and ask.
Good evening, sir. This side Gurminder.
Yes, ma'am.
This is
Hi.
really nice going through all steps and going part by part and learning everything. So my only one concern is this thing when we go to the class 12 standard student. up to what extent we should, tell them that, okay, bacha, this is as per CBSE, this much you have to be, learning for, for board point of view.
Ma'am, see, the answer to this question is very hard because I have seen some students of class 12 working with ensemble modeling, working with stacking, bagging, boosting. They work with a lot of features which we do not use.
Yes,
So, I
sir.
mean, there is a stacking feature in this or boosting. You can use gradient boost. They can add in multiple models on the top, one on the top of each, add a stacking. That stacking goes to my test and learn. So, for each student, it would be different. What the CBSE envisions is that let us make it less daunting for students, that they don't fear the subject. So any student who is on one learning track should also be able to work. Any student on a higher learning track should also be able to do. But I recommend that Orange as a tool is good up to class 10, maybe parts of class 11. For 12th, they should prototype using Orange. They should be able to complete the flow, understand, yes, it is working, and then try to implement the same in Python because that gives them a very clear understanding that I had to input the data, clean it, then train test split, then apply some model, then evaluate it, understand or interpret the evaluation, and every step would reduce to 3 or 4 lines of code in Python. That becomes easy for them.
Thank you so much, sir. Thanks a lot.
Sir,
Yes, ma'am,
good
please.
evening, sir.
Good
This is
evening.
Kalpana Gupta from Jaipur.
Yes, yes, please.
Sir, I wanted to know whether project developed in Orange without Python coding would be sufficient for submission in
Ma'am,
the
see,
12th class?
again, answer to the question would be the same. There may be
Mm-hmm.
some student who would be very comfortable coding, right? There may be some student who might not be very comfortable coding, but they might feel that I'm not getting enough from this tool.
Mm-hmm.
So there would be students who would be working with Python, they might be working with deep learning. I can't compare. I mean, and that happens in my classes also with higher education. I'm teaching machine learning to 7 semester students. Some of
Mm-hmm.
them are so advanced that I have to create a differentiated content for them. But for some of them, I have to keep it to absolute basic. So
Mm.
this would be something that as a teacher, you are the best judge that what, but yes, please do encourage them that even if they are creating a project in Orange by themselves, that is worthy. That's not that no, your project would not be considered because you are not using Python. Ideally, that should not be the case because their project work includes both.
Includes both. Okay, thank you, sir. And one more thing, sir, I would like to discuss here about 10th class also.
Mhm.
Like 10th class also they have included Orange, and just they have included data representation using Orange, like different charts they have included in that.
Yes, ma'am.
So that is sufficient to discuss with the 10th class students.
Ma'am, for 10th, I recommend that the student should be able to load data, visualize it
Mm.
using multiple tools, look
Mm.
at the feature statistics, how it is distributed, maybe
Mm.
also understand what is embedding. So what happens when I convert an image to numeric form? What is
Mm.
embedding? What happens when I convert text to embedded form? So
Mm.
if they play around with these things, it becomes easy for them to understand that yes, machine learning works only on numeric data. The numeric data gets converted to the form of vectors. For those conversions, we require embedding algorithm. That much is already
Okay.
good enough. Yeah,
Okay. Thank you so much, sir.
my pleasure.
Sir, one more thing. Can we again listen to your this webinar if it is available on net?
Ma'am, it would be on YouTube, certainly. This
Okay,
recording
okay.
would be
Thank you.
on YouTube. You will have the
Yes, sir.
link.
Okay, thank you, sir. It will greatly help us to
Pleasure.
like
My pleasure.
revisit.
My
Thank
pleasure.
you.
On the chat, Archana is asking for an attendance link. Yes, certainly you are going to get it. Thank you so much, everyone.
Hello, sir. Good
I
evening.
love talking to all of you. Yes, there is a question.
Yeah, sir. Regarding your first lecture, few points I have missed. So we'll be getting the YouTube link in the WhatsApp group, or whether where we'll be able to see your recording of this session.
The recording of this session goes to our YouTube channel, ma'am. Sultan
Okay.
Chand and Sons maintains a YouTube channel. Ashish sir shared the link. All of
Okay.
the videos are available on that.
Okay. 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 Because of the internet, few points I have missed. So I just want to regain that. So,
I am available to you. Anytime you put up a query on the group, you
okay.
always have an answer.
Yeah. Yeah.
Correct?
Thank you. So regarding projects, actually, we want to have a session because what type of projects we can give to 10th and 12th standard students.
Ma'am, that is one hard part of telling because we work with a very different, lot of different kind of projects. Even with
Okay.
Method AI platform, we are bringing in projects ranging from Orange up to, in fact, we are trying to take it up to deep learning also. Where
Okay.
different learners want different kind of projects. So
Mhm.
it becomes very difficult to create a session which would say that this is a general thing that you can do in projects. So that would vary
Okay.
from student to student and very
Okay.
difficult to generalize.
Okay, sir.
Ma'am, good evening, sir. This is Radhika. Can we, can you say any one project, specific project, which we can also as a teacher learn as a capstone project for 12th standard?
Ma'am, just
Uh,
suggest me something. Matlab, you want a Python project? I'll share complete pipeline from Python project end to end, from bringing in data to cleaning, 10 test plate and everything. If we want it that way, we can do it. But would you like the project to be something which is in image category? It's a different project. If it is text category, it's a different project. And
Only one or
if it
two
is,
example type projects so that we can also
we'll
learn from
take it.
that project. Yeah, yeah.
I'll take it with Python,
Yes, sir.
Yeah, sir. No problem.
certainly.
No problem. Thank you so much, sir. Thank you so much.
All right, thank you everyone. I see there are no more questions in here. And yes, you can refer to student.methodai.com for the projects. There are a lot of projects that we have added there. And pleasure always speaking to all of you.
Thank you once again, Dr. Gupta, for this interactive and informative session, as it always has been. And thank you, dear educators, for being there. We'll soon have another session. Do join in. Have a great weekend. Thank you.